Assalamualaikum, kami daripada Grup L. Kami akan membentangkan topik pasal Triangular Wave Oscillator. Apa itu Triangular Wave Oscillator? Triangular Oscillator ni kita akan tukar kepada square wave kepada triangular wave shape. Macam yang dinyata sini. A triangular wave oscillator is an electric circuit that generates a triangular waveform, which is its non-sinusoidal waveform characterized by linear rise and fall in voltage or current over time, creating a triangular shape. Okay. Triangular waveform ada dua key stage, iaitu square wave generator and integrator. Okay. Square wave generator ni kita akan tukarkan daripada sinusoidal kepada square wave, dan apabila dimasukkan integrator, graf dia akan bertukar kepada triangular wave.
In this topic, we need to know how circuit operation work. There are got two conditions, which is we have startup condition and system condition. So let's begin with startup condition. Now let's look at the point on the right. Firstly, when turned on, the output voltage will be at some initial value. This means that as soon as the circuit receives power, there are immediate, often non-zero voltage at the output. It will start at a certain level. Secondly, the waveform can be influenced by the capacitance charge and the amplifier voltage offset. This is crucial. This is because capacitors store energy, and during the stop, their charging or discharging can significantly affect the shape of the output signal or waveform. Thirdly, an integrated circuit usually takes input voltage and produces an output that can be integral over the input. This describes the typical function of many integrated circuits, particularly those used in analog applications like signal process. Finally, in this case, the integrated input is the comparator output, which is a square wave. This specific point clarifies a particular scenario. It tells us what with this integrated circuit, integrator receives its input from a comparator.
Okay, for the sustain conditions, when the comparator output is at voltage level like positive 2.5 volt, the integrators ramps up the output voltage linearly. Otherwise, the comparator switches to the other voltage level and the integrator will ramp down the voltage level linearly. Other than that, total phase shift around the feedback loop at 0 degrees or 360 degrees and the loop must be exactly 1. But if the gain is too low, the oscillator dies up, and if the gain is too high, the output will click. So here we can see the important formula for the triangular wave oscillator. So in this formula, it is used to calculate the period and the frequency of the wave. Application of the oscillator. There have three types of application of the oscillator, which is sweep circuits, PWM circuits, and motor control systems. For switch circuits, the definition of the switch circuits is an electronic circuit that produces a time-varying voltage or current, often used to control the movement of an electron beam in devices like oscilloscope or television screens. Triangular waves are ideal for sweep circuits, which are used to generate a time-varying signal that sweeps across a range of values. This is crucial for driving oscilloscope and other display devices where accurate time-based generation is essential. For PWM circuits, the definition of PWM circuits is an electronic circuit that generates a digital signal consisting of pulse width, varying width, pulse width modulation (PWM) circuit use triangular wave to control the width of the pulse, which is used in power supply to regulate voltage and current. The precision of the triangular wave is critical for achieving stable and efficient voltage regulation.
Next is motor control system. A motor control system is a device or group of devices that regulates the operation of an electric motor. Triangular wave oscillators are used in motor control systems to manage motor speed and position. The waveform helps in accurately controlling the motor's operation. In conclusion, the triangular wave oscillator is a vital circuit in electronics that generates a precise linear rising and falling waveform used in various applications. It operates through the integration of a square wave signal typically produced by a comparator, resulting in a continuous triangular output. Proper circuit design ensures stable oscillation by maintaining the correct gain and feedback conditions. Triangular wave oscillators plays an essential role in systems like PWM controllers, motor drive, and sweep circuits, showcasing their importance in both analog and digital electronics. That's all for our presentation. These are the references that we use in order to create this video. I will be putting all the links within the description below. And thank you for listening, and that's all. The end.